All right, let's dive into a really fascinating question. Can we actually teach AI to understand how we feel? We're going to break down some incredible research from Korea University that might just have cracked the code.
You've been there, right? That super frustrating moment when you're talking to a smart device and it just completely misses the point because it doesn't get your tone? Well, this isn't just a small bug, it's a huge wall between us and our tech. And it's exactly the problem these researchers decided to tackle head-on.
And this is the perfect example. The words say one thing, I'm fine, but the voice, the tone, says something totally different. A basic AI just hears the words and gets it completely wrong. This kind of failure, this inability to read between the lines, is exactly why we need a much smarter, more empathetic kind of AI.
So, if just listening to our words isn't going to cut it, how can an AI possibly get a real read on our feelings? Well, the key is to stop trying to understand us with just one sense. To really get us, a system needs to learn from a bunch of different channels all at once. And that brings us to a super important concept called multimodal learning.
Think of it this way. Instead of just reading the text of what you're saying, the AI is also watching your facial expressions, listening to the tone of your voice, and maybe even monitoring your brain activity with something called an EEG. It's about combining all these different streams of information to get a much richer, way more accurate picture of what's actually going on inside your head.
But, of course, it's never that easy. Real-world data is, well, it's a mess. Brainwave signals can be fuzzy, let's be honest. We're not always great at describing our own feelings, and sometimes the signals completely contradict each other. You know, like a big smile paired with really anxious brain activity. These are absolutely massive hurdles for any AI to try and jump over.
So how in the world did these researchers manage to cut through all that chaos? Well, they came up with a core insight that is both incredibly powerful and just beautifully simple.
And here it is, that big aha moment. Even though a brainwave pattern looks nothing like a facial expression, if they are both capturing the emotion of, say, joy, then deep down they should be telling the same basic story. This amazing idea is called cross-modal semantic consistency, and it becomes the foundation for their entire solution.
Now here's the really clever part. That disagreement between signals, it's not a problem to be thrown out, it's actually super useful data. When the AI sees a mismatch between brainwaves and a facial expression, it's like a big red flag goes up. It tells the system, hey, hold on, something's off here. This data point is ambiguous, so I better be careful with it.
So, to put this whole idea into practice, the researchers built this awesome two-part solution. And the first part uses a brilliant analogy, a wise teacher guiding a student.
Okay, so this process is known as knowledge distillation, and it works kind of like this. You have a teacher model that gets to learn from high-quality video, which is packed with all sorts of rich emotional cues. Then, it takes all that deep understanding and transfers it to a student model that's stuck looking at really noisy, messy EEG signals. The teacher literally shows the student how to find the real emotional patterns that are hidden inside all that noise. But teaching the AI is just one piece of the puzzle. The second part of this whole solution is about making the AI a much smarter and way more efficient learner. You know, the old way of training an AI is just brutal. It means humans have to sit there and manually label thousands and thousands of data points. It's incredibly slow and super expensive. This new method, though, uses a technique called active learning, which is just so much smarter.
Remember how those inconsistencies, those mismatches, are actually useful? Well, here's where it all pays off. The system automatically finds the moments it's most confused about, those times when the brain waves and the facial expressions just don't seem to line up. Then it actively asks a human for the correct label for only those really tricky examples. This just massively boosts the learning speed and cuts down on the cost. It's a total game changer.
Okay, so that all sounds pretty great in theory, but does this two-part solution actually work when you put it to the test? Well, the results are pretty amazing to look at. So this is what you get with the older models. When they try to map out emotions from brainwaves, everything is just scattered and overlapping. The AI basically can't tell the difference between different emotional states. It's just looking at a jumbled, chaotic mess. But now, look at this. This is the after. With the new method, the same data gets organized into these clean, distinct, tight little groups. This is a massive leap forward. Suddenly, negative, neutral, and positive states are all perfectly separated. The system has literally turned chaos into clarity, which means it can recognize emotions way more reliably.
And the numbers totally back this up. This chart shows the performance boost, and you might think, oh, a couple of percentage points. But in this field, that is a really big deal. This method delivers a solid, significant jump in accuracy over the old baseline models, proving that it really, really works.
So, what's the big takeaway from all this? This isn't just some abstract academic project. This kind of breakthrough has huge real-world implications for building better brain-computer interfaces, or BCIs. That's technology that can actually understand and adapt to what's going on inside our minds.
And that brings us to the future, and the really exciting question of, what happens next? As the researchers put it themselves, this isn't the final answer, but it's a huge step in the right direction. By focusing on consistency to handle all that messy, uncertain data, their whole framework makes AI more robust, more efficient, and, most importantly, more trustworthy.
So this research gives us a powerful new toolkit for teaching machines to finally understand our feelings. And it leaves us with this incredible question: what's next? As these systems get better and better at understanding us, how is our relationship with technology itself going to change? It's a future that's taking shape right now thanks to amazing work just like this.